Live. All right, we're going live. Let's see. Let's broadcast the link, invitation link. I've just tweeted that, and you can retweet. I think it's the event page that we need. Let's try that.
Yep.
We're starting okay, so let's see if some people join us. By the way, we're producing IPython notebooks like crazy over here.
Yeah,
that's wonderful.
I can imagine. That's
No, and we're very much looking forward to the feedback that you guys collect from using it in this context. I think it's going to be a very enlightening source of information for us, and I'm sure there's going to be all kinds of little issues that you're going to run into, but it's going to be super useful for us to understand how the tool can be used in a context like that.
And also, we are inviting other people who want to create their own to submit notebooks or maybe some other documents, but in general, we are encouraging IPython notebooks as a form of contribution for alternative assignments. So we've created a different repository on GitHub that is called the Assignment Bank. This is something I stole from other connected educators on the internet. An assignment bank where people can contribute their own different problems or programming exercises that in some way could have been the assessment we could have used for, say, numerical methods, Euler methods, or for PDEs, and so on as we progress in the course. And we're starting to see a couple of people contribute to that repository via pull requests. And the idea, of course, is that we have created some IPython notebooks to as one potential learning pathway to this content, but there are infinite ways one could want to learn this content, and the most effective way for someone who is a learner following this course to actually master the content is by creating their own content, because just reading what we decided might be a good way to present a say a particular scheme for a partial differential equation might not click with them, and creating their own content, they will really, manipulate those concepts and come to master it. So that's the idea. I hope we get some more contributions. We're trying to encourage people to really take ownership of their own learning by creating some content themselves, and we're using GitHub quite a lot. So we now have 12 viewers joining us, and let me, as we start, let me tell you in 5 minutes one anecdote about my first use of IPython notebooks for teaching. As you know, Fernando, you installed my first full distribution with the IPython distribution with the IPython notebooks at that conference some while back, and that started a whole history, right?
Right before you got on the plane. I remember you were flying to Chile for a conference within hours, and we were frantically at ICER at Brown, frantically getting it ready just before you got on the plane.
On the coffee break, installing everything on my laptop so I could work on things on the plane.
Exactly. And that was coincidentally the day that we got the grant to support the notebook development.
That's right, because you heard from the Sloan Foundation, you heard at that time, and it was a fantastically exciting moment, and that started it all for me with IPython notebooks.
Great.
So we more intensely created some IPython notebooks for a CFD class with the help of my brilliant PhD student, Gilbert, who might not be listening, but he now is recorded for posterity. His contribution was really good. He helped me. We bounced ideas, we wrote things together. And it was based
was that your 12 steps to Navier-Stokes
That's
collection?
right. That's right. So the thing is, I was using this module, this was inspired by my postdoc Rio Yokota as well, so everything's team effort. I had been using this exercise in class, in the CFD class, live in a classroom as the initial practical module for the class, and it usually took about 4 to 5 weeks for the students in the classroom to go through this whole set of exercises. And I was asked to lead one summer school, and I had 2 days, and 8 hours per day, 2 days for an intense CFD course in Argentina. Yeah. And we prepared these IPython notebooks with the idea, we had a diverse audience, physicists, engineers, mathematicians, master's degree, undergraduates, even some PhDs there in this summer school, and I thought everybody's going to have different skills, and so I need to allow the students to go at their own pace. And by writing everything into the IPython notebooks, I thought, well, I'll have them go through the material at their own pace and help them desk to desk and see how far they go. At the end of the 2 days, about 5 students had completed the 12 steps and actually had been able to write a 2D Navier-Stokes solver from scratch on Python.
Nice.
About 8 sort of in the middle, there was 20 students in the course, about 8 in the middle sort of got anywhere between, step 8, 9, or 10, so of those 12 exercises. And then there was a little tail of a few students back that only, got past 4 or 5, which is kind of usual what you have in a class. Mm-hmm. But what was amazing to me was to think that 5 students of that group had actually coded a 2D Navier-Stokes solver from scratch in 2 days. Mm-hmm. And that was just amazing. They were following this sort of scaffolding that was created by the IPython notebooks, reading and writing code as they were following the examples, and I was answering questions desk to desk. So that was my first experience with IPython notebooks, and the rest is history, as they say, because now I've incorporated it in almost every course since then, and now we're sharing that with more than 3,000 people in the numerical methods MOOC that we're running.
So that is your current enrollment right now? You have roughly 3,000 enrolled students in the course?
Yeah, 3,000. Well,
wow.
3,030 people enrolled, including staff, which is ourselves and my PhD students, and the co-teachers at Southampton University and Universidad Católica de Chile, Catholic University of Chile. We have parallel courses being taught at these 2 universities, and the instructors will all discuss the material and give each other peer review and participate in discussion boards. So there's kind of this connection of 3 courses going on, connected through the MOOC, and in addition, people following who knows where online.
Nice.
And at the when you taught it in Argentina at this summer school, the entire 2 days they were doing hands-on work, and it was kind of a flipped model where they were doing all the work and you were there only answering their questions and working with them, but you were not lecturing from the notebooks. They were using them as self-guided work documents.
Correct. I didn't lecture. I on occasion would stop and say, okay, I need to clarify this because the question has come up more than once, and do a 2-minute on the board explanation, or maybe I would have some sort of brief summary of something in the beginning of each section of the day. Very brief explanations, but really no lecturing whatsoever. The material was for them to read and interact with through the notebook. So the notebook became sort of their coding tutorial and a repository of all the content at the same time.
Mm-hmm. Mm-hmm. And what, for us, one of the things that's very important is to understand what are the sort of the failure modes or the difficulties or the areas in which things don't quite work as well as perhaps they should. This is in many ways kind of uncharted waters in terms of how we are changing how we teach computational computational methods in whatever the discipline. In this case, it was computational fluid dynamics, but the same thing could apply to data analysis in ecology, or to genomics, or to astronomical data. In what ways did you find that this change of tooling and mode didn't work as well as you would have wanted it to, or what are kind of the ways in which you felt that maybe we can do better with the design of the tool, that we can explore new ways of using it, or that there are things that we flat out need to fix? Because we do know that there's lots of problems actually with the tool. It's by no means perfect, but we're constantly interested in this kind of feedback that comes from the real world, because it's very different to have kind of people often make requests of, oh, I would like this, because they think they would like it, and sure, obviously there's value in that information, but we think it's a lot more valuable when people say, no, I actually tried to do this in this context and it didn't work. And it didn't work because my students couldn't do X or Y or Z, and we failed at achieving a specific learning objective, or at this part of the workflow was miserable, and then that is very clearly a problem that we need to address, and it's very actionable information that we can use to prioritize what aspects we work on and which ones we don't, given that we have finite resources.
I didn't encounter one particular thing that I would say, was an obstacle. Since then, of course, we have a new release. At the time, it was not possible to navigate a directory tree once you were on the notebook, and that made a big difference. Students expected to be able to do that, and they couldn't. And so a lot of it is, nowadays I find students in my classroom as well, I find most of them are really not familiar with navigating on the terminal window. They're not, a lot of students are they really don't know how to use computers. They really can only point and click.
Yeah.
They do not know how to use computers. And so part of
and you're talking about engineers and physicists studying fluid dynamics here.
Yes. So part of the challenge is this process of unlearning those habits of, I have to be able to point and click to solve the solution. It's in their mind that they just should be able to point and click to do anything. So I find a lot of it, a lot of initial friction, installation friction is a big deal always in a class. When you start up a new course, that's a big deal. So having an option to try something on the cloud, or on a cloud instance, immediately some sort of a sandbox for students to play around with something before they need to download and install, so that they get the taste for it. That's a big deal.
That would be useful?
Yeah.
Would that be? Okay,
yes, because I often find that students will they don't want to download and install things before they really believe that they want it.
Yeah.
Very, very useful. Okay. Now we're paying attention. I'm taking notes on all of this as we speak, because this is really important. I mean, we're hoping this discussion will be useful for the general public, but I think for Brian and me, in many ways, this is interesting, really, as an exercise in us understanding what the project can do to better serve scientists and educators.
But you need to tell me more as well about other people using IPython notebooks in education, so that we get a broader idea of people adopting IPython notebooks. What are they doing? Are they doing different things? Are they, one thing I discovered actually this week is for my IPython notebooks, my students, many of them print them out.
Interesting.
Yeah, that's interesting.
And
so
I was surprised.
They just convert them to HTML or PDF and hit print and read them as documents.
The issue for them is that no solution there prints them out like they want them, because they're
just printing from the browser.
They're printing from the browser, and that cuts some lines or some.
Yeah, it doesn't work very well.
It doesn't work terribly well, and so I've had students ask me, well, can you provide a PDF version of this? And I tried with them. We convert. Then I have my HTML style, so. Then you can convert to LaTeX and try to, from LaTeX, to go over from PDF. It would take a lot of work for me to sort out the styling. Moving to, to produce a printed version that actually looks nice, because it matters to me that it looks nice. And as you notice, I work quite hard on my notebooks.
You're well known. You're famous for producing the most elegantly styled notebooks out there and the most carefully curated ones. It's no accident that the iPad app chose your materials as the example gallery. And so I'm not surprised. Yeah. I'm not surprised about this, and we're taking notes.
Right. So if I want them to be printable and they still maintain their prettiness. So that would be nice if you could print a notebook in a way that is graceful.
Yeah. Both easy to do for the student, yes, in terms of their own workflow, so that it doesn't distract them and it doesn't become an afternoon project. How do I print this thing? And then the next thing they know, they've forgotten what they were trying to learn. But also that the printout comes out as something nice and beautiful.
And that it doesn't require me to do the double work of styling and LaTeX.
Yeah. That's very painful.
No. This is an absolutely valid concern. Maybe
I'm using them as documents that actually contain a lot of textbook material.
Yes. Right? No, and we would like to see. I mean, when we present kind of this vision of this environment as a way of bridging the entire cycle of computational research from the work that a scientist does when you're exploring an idea and you just open something and you start typing code and you run some algorithms and you look at some plots because you have an idea that you want to test, to the point where you gradually build up some notes around it and you take notes for yourself, maybe for your collaborators, all the way to the point where you say, oh, this is going to become a research paper, this is going to become a book, or this is going to become teaching materials. We really want that workflow to be smooth along the way, so that at any point you can reuse your notes in your article or in your book, or you can reproduce your research, you can go back to an exploratory mode. And if we create hard transition points where all of a sudden we say, okay, well, now that you've done all this work, if you really want it to look pretty, you have to copy it over here and abandon and do something completely different, that precisely breaks that continuity and that fluidity that we want. The moment we break that, we know that reproducibility goes out the window, the ease of reuse and genuinely rebuilding goes out the window, and so we have to find ways of not breaking that fluidity and taking those barriers down. And that's kind of the challenge for the project, is how can we come up with solutions for that problem that don't impose that burden on you.
And tell me more now about other uses of IPython notebooks in education that you know about and that might.
Well, it's probably worth listing mentioning for readers the gallery. On our wiki. On our wiki, there is a page called a gallery of interesting IPython notebooks. Maybe we can paste that link on the. I don't know if we paste links on the public chat room. Do we? I think if I paste them here, IPython.
This
gallery.
Is group chat.
Yeah,
I don't know if it's
I just shared. I pasted share on the event page, and I'm hoping that will show. Did that show up?
That probably does show up.
Okay, so this is the first time that we have a formal event hangout, and so I'm not completely sure about the logistics. But yes, it seems like that IPython gallery. No, but I pasted the wrong thing. I pasted the wrong thing.
So we now have. Sorry, I've just clicked on something. I'm also just learning this interface for the Google Hangout on Air, and just clicked on a Q&A app, and I'm getting some questions that I hadn't noticed.
Great.
So I have a question from Greg Wilson. Are you students sharing notebooks through Git or some other version control system? So what are the experiences? And then Tiago Antao, I am developing pop genetics. In IPython notebooks.
I hadn't seen the Q&A thing. Brian, did you see the Q&A thing?
I'm reading them out.
It's on the left. If you click on below the little, it has a little blue thing.
Oh, there we go.
Says Q&A, and now we can see. Okay, good. We can see the audience questions. Great.
Oh, yes.
That's fantastic.
Oh, fantastic.
So,
okay. Well, we hadn't seen that, so let's.
The biggest problem that he has is distribution. It's hard to install the whole soft stack on students that are not computer savvy. We were talking about that a moment ago.
Exactly. So should we take these questions kind of in order?
Okay, go for it.
is Greg Wilson. So let's read it again for those who are watching.
Right.
Greg Wilson asks, are your students sharing notebooks through Git or some other version control systems? If so, what have then their experience has been with diffing and merging? It's a headache for software carpentry. And I would say that Greg knows better than anyone how much this is an issue, because in fact he mentored some University of Toronto students who developed NBDiff, which is a tool to try to assist with diffing and merging. It was a great prototype. Unfortunately, right now it's still at the prototype stage, and no one has really picked up the NBDiff tool. NBDiff is here, NBDiff. nbdiff.org. I've just shared the link on the public page. And NBDiff is a great start on the problem, but we obviously need to do more. In the meantime, because a full-blown tool like that is a fair amount of work to develop. Thomas Kloiver, who's one of our core developers and a postdoc working with me here at Berkeley, recently developed a tool that you can install as a Git hook, and that helps you basically get a flat version of the notebook so that you can see the diffs more easily. So it basically strips out all of the images and everything else from the notebook, so that when you view the diff of a notebook, you're seeing a diff of the text, you're seeing a diff of the code and the markdown, and so that the diffs are actually humanly interpretable. The merging step is still may be done with the full notebook, but by having this thing that helps you as a human being understand the diff, rather than seeing a monstrosity that has prompts and metadata and binary output and all of that, at least it's easier to reason about the workflow. So both NBDiff and what Thomas did are, oh, I'm sorry, Greg pointed out that the students who were at Concordia University in Montreal and not in Toronto, and that is my fault. Greg did not misrepresent them. That is my misremembering what university they came from. Since I met Greg at UToronto, I mistakenly thought that they were his students. I apologize to Greg and to the students, but that's my fault, not his. And so, but this is something where we do know that we still have tons of work to do. The workflow for version control is not what we want it to be. Absolutely not.
And actually, I would say, in my experience, forget about diffing and merging. Let's just say you wanted to use Git to synchronize content, either for faculty or instructors to distribute material to the students, or for students to turn material in. In my experience, even without diffing and merging, Git is an unmitigated disaster, unless you go and teach students the full Git experience and workflow. And I think all of us who use Git daily know how to do that. We know how to branch and merge and rebase and manage all these things. And even in a context where we're careful, so we make sure that there's never a conflict in a notebook that we have to resolve, as Fernando's been describing. But for the audiences that you're talking about, Lorena, where just the installation, the basic computer skills of the students are really a challenge, forget about Git. Like, it's an absolute disaster. And this is, I think, in my mind, the distribution and the course management around notebooks is a really hard problem when you accept that Git is not a solution to that in many contexts. I mean, there's some contexts, for example, at our university, when we teach scientific computing to physics majors, we actually teach Git in its full glory, and in that context it's fine. But that's a bit of an unusual audience, and I mean, Greg knows this well, that Git is a very painful experience for many users. And so I'm looking at maybe using Dropbox, but there's problems with Dropbox. I'm looking at writing some sort of custom service that's hosted in the cloud that allows people to easily exchange materials. And the other important abstraction here is that in a course context, much of the time, the operation you want to do is actually to make a copy, not have a synchronized version. For example, when I give students lecture material, I don't want them modifying my lecture material. They just need a copy. When they're handing homework in to me, it can be a copy. It doesn't need to be synchronized in the usual Git Dropbox sense. And so I mean, obviously email is a solution, but even that's horribly painful. Course management systems like Piazza or Moodle allow you to post content, but again, it's really, really painful. And so this area of course management is, I think, a huge problem that we need to think more about, even though it's sort of outside the context of the narrow notebook user interface. So I'm really curious to hear from you, Lorena. How do you distribute course materials, get homework back from students, etc.?
We're using GitHub, and so what I did in the classroom was we got students started with GitHub immediately using the GUI, so that they can literally just clone, edit, commit, push. That's all. That's all we get them started with that. The materials are all the course materials that we are producing as the instructors with Ian Hawk in Southampton and Carlos in Chile, Carlos Jerez. Those materials are all being developed on GitHub, and the students are given plenty of opportunities to find this through links to NB Viewer so they can read them, but always with always with the tip of, you know, if you want really to get this material, you have to go to the source here and download, clone, etc. So there are various levels. Some students have actually, they bite the bullet and they do start learning Git, and they realize the value of it, and slowly they start learning the command line options. We also installed a Wakari Enterprise Python on the Cloud server here in the class at GW for my classroom students. That's not available for the of course followers of the course in the MOOC version. Of course, they can open a Wakari free account if they want to, and we'll give them some instructions on how to do that. But for the on-campus students, we have a Wakari Enterprise server installed here so that they always have Python on the cloud, and a lot of them are using that. Now, here is an interesting thing. The free Wakari accounts, you can easily give a GitHub URL and it'll clone your GitHub, or you can git clone on the terminal in a Wakari terminal. But the enterprise version turned out to be a lot more convoluted to be able to use GitHub, and that became an issue because the students who are using the Wakari on Python on the cloud are the ones who are less prone to be using GitHub because they don't, you know, it's not so easy.
Yeah.
But all of them have been made to at least get the material from the GitHub repository. The GitHub repository of the course has, I think, almost 400 forks right now, so we know people are forking the material. I don't know how many of those are course followers or just fans we have or what. But let me see if we can find more questions here.
Yeah, we have several, and we should try to keep the flow. Maybe we skip Greg for once to give another person a chance, and we'll come back to Greg. The next
my co-instructor is saying that he wants a commenting layer facility to the Jupyter Collaboratory. For education, we could have the students comment or question on the code in real time, and it could see, and all could see the questions and answers. Ah, interesting. Okay.
So there's a couple of aspects to that, and I think eventually we will get something of that nature, but I think with commenting it's probably worth thinking at two levels. One is the issue of more of a real-time chat where you sort of type comments and you could have like a side chat channel. That actually is probably not particularly difficult to add, and it's something that somebody could probably even hook up. Now that the Jupyter Hub is a Node.js facility, I'm sure there's a million Node.js chatbots out there that you could add as a service on the side,
or even just embed Google Chat. I mean, that would be very simple.
Exactly. I think the more interesting one that we've been thinking quite a bit about, but we haven't really crossed the line of implementing anything yet, is the notion of adding a persistent layer of comments into a notebook, where now you have per cell comments, and you actually can, each comment may have responses, sort of like what you can do in Google Docs, where you can highlight a section of text and add a comment, and that comment can have responses, etc. Because for collaborative work on documents, that actually can be very valuable. We sort of have the pieces of infrastructure to hook that in, because every piece of the notebook has metadata, and so you can imagine we have fairly fine granularity levels to attach information to pieces, to areas of a notebook, but we haven't really crossed the line of implementing anything. There's a few tools out there. There's a very interesting project from a startup in the Bay Area called Hypothesis that we have met with the principals at Hypothesis. We have discussed this, but we haven't really done anything. Part of it is just sheer bandwidth and manpower. We're a small team. We're already way behind on many things as it is, and hopefully if we can get some more resources and more people contributing and helping, some of these other ideas can be picked up, because right now that's mostly in the idea board. And Brian, I don't know, I know you've thought a lot about the commenting issue. I don't know if you have anything else that you'd like to pitch in.
Well, on the collaboratory side, so actually a previous version of collaboratory did have commenting built in. As they transitioned to new code, that feature ended up getting removed. That is something that there are plans to add it directly to collaboratory. But as Fernando said, it's not just in collaboratory. It's something that we want to support within the project as a whole.
Because go ahead.
Ian says that he's thinking something of the style of Etherpad.
Yeah, I mean the exact model of what that would look like, we probably, that's starting to get into more implementation specific details than we have in mind, because we want something that fits within the document model of the notebook and in the long term view. Now you could imagine in a class project simply running Etherpad on the side and attaching the Etherpad logs, storing the Etherpad log as a text log in that same repo, so that once a day or something you synchronize the Etherpad log into the repo, for example, so that you have chat logs associated with it. That would be kind of a duct tape manual way of doing it for now. And we sort of encourage a little bit that kind of exploration, where people try things out, and if a specific model of working turns out to work really well, we can say, okay, well, now how do we capture that into the more permanent structure? Because for things that we want to put in the document itself, well, we think of these documents as ways of storing computational research work as an archival format for the long haul. We want these things to be readable and machine readable and human readable 10, 20 years from now. So we're not going to throw every conceivable hack from the internet out into the document format overnight. But it's interesting, if people explore these ideas and something turns out to be a wonderful workflow in practice, then that again is actionable feedback for us to try to incorporate.
So Greg said something about whether Brian just mentioned that he was going to reinvent SharePoint, something like that. Where is it?
Yes. Did Brian just say he was going to reinvent SharePoint, but for notebooks? I don't know what that means.
Yeah, me neither.
Brian, do you know what that means?
I think SharePoint is a product for like shared directories, and I think it's a Microsoft thing. I'm not using that much. I don't exactly know, but no, I mean, I would say to Greg, I'm not volunteering to invent something like that. What I will say, though, is that we're going to solve this problem. I don't know how we're going to solve it. I don't know if it's going to be based on Git or Dropbox or Piazza or email or whatever it is. but for people to teach with a notebook, in particular in a scalable way, like Lorena is doing with that many students, we just have to solve these problems. And I'm guessing that the solution can't be one size fits all. For some audiences, Git may work well, and maybe for them we just need to solve the diffing and merging problem. In other audiences, maybe installation itself is just not possible, and so it has to be cloud-based, and the entire workflow of the course has to be in the cloud and hosted. And so, but we definitely have to solve these problems.
Maybe there should be some sort of discussion area for the particular sort of IPython notebooks and education concerns. I'm not sure if you could just have a sort of issue opened up or discussion on the GitHub, or the GitHub repository of IPython or some other. I don't know if you do. You guys have a mailing list or some other places where you?
We have a general mailing list, and I think there's enough overlap between researchers and educators in the mailing list and software engineers that we sort of welcome broad scope discussions to happen on the mailing list, and once things narrow down to the point of, oh, somebody should implement this thing, then it's a good time to open a GitHub issue for it and kind of start turning it into code. But our mailing list is kind of a very welcoming, fairly open environment, and we're happy to have folks participating there.
Okay, good.
Do you want to keep cycling the questions?
Yeah, let me jump to this one we've ignored for a while. Is Tiago asking, he mentions that his biggest problem, he's teaching population genetics with IPython Notebooks, and his biggest problem is distribution. It's hard to install the whole stack. Students are not computer savvy, and he was thinking of making a virtual box or a Docker, and he's asking for ideas.
Yeah, I think right now, if you want students to install something on their computer, that Anaconda is definitely the best option. In my mind, things like Docker and VirtualBox are sort of like regular expressions. You end up with two problems rather than just one. Although I will acknowledge Anaconda, in some contexts, for some students, is still painful.
They still have to go in a terminal and type IPython Notebooks, and for some reason, this causes a lot of stress.
Yeah, and even the Anaconda does have a launcher, an actual app that launches the IPython Notebook, but on Windows it launches a special subdirectory that's not really useful, and so. And
this has caused a lot of confusion in some of my students, because then they can't find, they're not in the right directory, they're not in the right working directory, and they can't find anything. And if they want to run one of the files that we've distributed to them, the file is not found.
Yeah, so I'm talking to Continuum about that. I've not gotten an answer back, so hopefully they'll be willing to rethink that decision. But the real answer to this, I think, is zero install contexts. And I would say that the main effort the project has in this direction is what we're calling Jupyter Hub. Jupyter Hub is a multi-user version of the IPython Notebook that you'll be able to install on a central server or in the cloud, and then give accounts to your students, and they can just log on. And in a context like that, installation completely vanishes.
But then you have to have a way to do version control on that as well. So the material, I would like my material to still reside on GitHub, but somehow be able to allow the material as a cloud Python experience that is always up to date somehow.
So right now, Thomas Kloiver is adding a terminal to the Notebook web app, and when you're running Jupyter Hub, you just have a full Unix environment, and you can issue Git commands and manage Git just like you would on any other system. And so I think that will definitely be possible and supported.
And we should mention that there are already Doug Blank, who's a computer science professor at Bryn Mawr. He's been very active. He's the project lead for the Calico project, that is a project for teaching introductory computer science and robotics with various languages. He's a heavy user of the notebook, and he's already been testing this fall Jupyter Hub basically from the very first day that the first rawest of the rawest prototypes was available on GitHub. Doug began testing it in production in teaching. And so he is using it to teach a course, and he has a hub server deployed. And we have other collaborators who are beginning to test installations of the hub. The project is already up on GitHub, and anyone can begin installing it and playing with it. And hopefully by the spring it'll start being a reasonably robust solution. So that at least is a tool that is becoming available pretty much now.
Yeah.
So the other question I have highlighted here from Subrata Sarkar, he says he's using it for a few months, IPython Notebooks, and he's wondering if it's possible to share a notebook on the web as in the notebook viewer, but that will be still interactive.
Yeah, so that's currently not possible, but we have very, very definite plans on enabling that with a variety of levels. It's worth pointing out that what still interactive means, there's levels of that. Do you mean still interactive by, can I execute arbitrary code? Can I type new commands and have them run? Or do you mean, can I run the control sliders that were there available so that I can see new versions of a parameter, but not actually change the code. Those are different levels, because one of those can be solved by basically pre-computing those values and caching them and serving them back. The other one requires, well, if you're allowed to type arbitrary new code, then you have to have really a server running full-blown in the back. But at least the ability to have interactive sliders and control remain live is something that we are very actively working on. It turns out to be a viciously complicated problem to do it right, like truly viciously complicated. And we've had enormous amounts of time has gone into that already in the fall, and it continues to be what we think of as a kind of an open research question. But we are making good progress. We're happy with the progress. We are moving forward on that. It's just really, really hard to do it right. And obviously, with something like if you have Jupyter Hub deployed, at least in a restricted context, it would be a lot easier to have a demo account that is always running, because the idea is you have a trusted environment and you know who your students are. So giving them a cloud-like version, since it's in your private servers, you have a lot less restrictions. It's an option.
Yeah.
Christian Ono is asking about. He said he's recently found out about Spider, the Spider IDE, and he wants to know if how IPython and Spider relate. Is exactly his question.
Brian, you want to comment on that one? I don't want to be the only one speaking.
Yeah. So I mean, Spider is a Qt-based IDE for Python, and it's open source, and it has a text editor, an embedded IPython console. They use the Qt console that is open source and that ships with IPython, but embedded in their application. And it also has some other really nice features around debugging and also the help system. So, for example, in Spider, if you look at a doc string, they actually run it through the NumPy doc conversion and Sphinx, and you get a really nice formatted doc string. And I know a lot of people who are using that, and I think it's a really nice sort of companion to the notebook when you really want more of an IDE workflow rather than the document-oriented interactive notebook experience. I mean, there's been, with the new kernel architecture that IPython has for running code in different languages, I've seen some people start to discuss extending Spider to not just focused on Python, but basically any language that could be supported within the IPython Jupyter ecosystem. And it really, in that case, I think it really just depends on the usage case. And that really is up to a particular user to figure out what the best tool for the job is.
And for example, Brian says it's heavily used. Actually, Thomas Kloiber, that we've spoken already about, Spider is his everyday environment. When he's doing code development, Thomas uses Spider, and he has contributed code to Spider, and the Spider developers have contributed code to IPython. IPython is not only the notebook. The notebook is a very high visibility aspect of the project, but the architecture is not just the notebook. The architecture really is about a protocol to enable interactive computing and to interact with an interactive process, right, as a human, right? And that protocol is supported by things like the terminal client and by things like the Qt console and other clients, but we are not trying to build an IDE. IDEs, building a good IDE is a big problem and is a big project, and we basically think that the Spider folks are doing a great job with that, and we are happy that they use IPython, and if in any way we can collaborate, then it's great if if IPython can serve their needs well, but doing a notebook type workflow is a different one from an IDE style workflow, and we sort of we have already enough scope creep as it is, and our own project has enough issues keeping a limited scope. Building a full-blown IDE is one bridge we don't want to cross, and so we're happy that that team is doing a great job. On Windows, for example, Visual Studio is another big IDE that does the same thing. It embeds IPython in a console. When you're doing Python in Visual Studio, you can have an embedded IPython console. We're not going to try to build Visual Studio. That's millions and millions of lines of code that have been developed for probably 2 decades, right? We're not going to go there, but we're happy that if you want an interactive console in that context, you can do it. And I think PyDev, the Python plugin for Eclipse, I think it also, or at least in the past, they've talked about also supporting IPython. So we're very happy that IDE projects like Spider or PyDev or Visual Studio can embed an IPython console inside of them. And even non-IDE systems that are more classic editors like Emacs and VI can also talk to IPython. So in Emacs, for years, this has been true for 10 years, you can open the Emacs Python mode in IPython instead of plain Python and work inside Emacs. And Paul Ivanov, who's one of our core developers, built a client so that you can control an IPython kernel in a VI session. So these kinds of integrations are things where we think the protocol and the architecture can support that without us having to try to stretch the limits of what the notebook does, so that the notebook is also an editor and also an IDE and also these other things.
So going back now in a related note to more the pedagogical aspect of this IDE IPython notebook combination, the question by Alex Saez was the following: do you think IPython Notebook is a good tool for learning programming in Python? Is it not strange for newcomers not using a regular IDE and saving scripts and so on? And you know, I understand, I think, his question, and I have found in some of my students when I see them working that some of them do, perhaps they have been exposed to MATLAB or other things, and they do want to go back to the IDE. They gravitate towards this safe zone of the IDE, and as they're developing their own code on the basis of the tutorial that was created and offered to them in the IPython notebook that we as instructors offered, they are working on the IDE. Mm-hmm. So I think from the student's point of view, there is, if they haven't been exposed to IPython notebooks before, there is a bit of sort of culture shock if they're used to using IDEs. But of course, IDE is just sort of the programming aspect, and the IPython notebook, for me, is much more than that. It's a full document that can contain a rich variety of content, and I want the students to discover that as well, and find that they want to use them. You know, for example, use them in a way that is more appropriate to the notebook, like dividing and chunking up their code and not writing just in one big cell a whole screen load of mm-hmm. code in one cell, and using it like an IDE, which I've seen some students do as well. So, mm-hmm. so I think they do need a little bit of guidance on how to combine these two tools. What do you think, Brian? Have you encountered that as well, that duality?
Yeah. So I think it's a question of the audience and the usage case. I mean, if you're learning to program and building web apps or distributed systems or something, the notebook is a horrible tool. I mean, it really is. If you're someone who is going to spend 90% of your time working interactively, well, then the notebook is a fantastic tool for just learning Python. But what Fernando has said about IPython is not going to grow into an IDE. I want to affirm that, at the same time say that we understand that as notebooks grow, eventually you need to turn that code into a standalone script or parts of that code. And right now, you basically have to use a different tool. You have to pick your favorite text editor, and where that becomes a problem is if the notebook is running on a remote server, right? If you're running the notebook on your own machine, you can fire up TextMate or VI or Emacs and edit that file. If it's on a remote server, you're dead in the water. And so this is something we're aware of, and it's going to be more relevant as Jupyter Hub and other sort of remote deployments of the notebook become a reality. And we don't quite know the answer to this yet, but again, it's something we have to solve. And yeah, so we'll figure this out, but it's going to take us a little while.
And this is something where we've started experimenting with IDEs. Again, Thomas actually has a little extension called Cell2Func, which is a little cell magic that will grab an interactive cell and basically analyze its AST, indent it for spaces, give it a function signature, and replace it with a function call that produces the equivalent state, but now you have a function snippet. That makes it easier to put into a file. We're toying with ideas of, for example, could you automatically have an extension that creates a module version out of a notebook, so that extracts from a given notebook the parts that are class declarations and function declarations and leaves out kind of the interactive, the script part, and has the reusable components automatically saved for you in the back, so that if you have multiple notebooks, they can start reusing their functions without copying and pasting. So we are aware that there's a problem here, but we also think it's actually kind of an open question in terms of how do we move in this fluid boundary between interactive exploration and reusable software components that need to be long-term standalone library style? And the issue there is that, as you pointed out, in the notebook environment, the focus is on the narrative. The focus is on the story, on combining content and maybe text and maybe an explanation with a bit of code, right? Whereas in the reusable component, that changes. The focus becomes the code, the functions, the classes, and they're standalone. They need to be automatically tested. They need to be reliable. They need to have a clean API. But those two are not a black and white, worlds apart reality. There's kind of a fluid. There's a fluid process between them, right? You may want to go back to your library and explore it interactively. And so we see this as a very interesting open question. What are the tools that we need to imagine and the workflows that we need to imagine to enable both of those processes to be efficient? We want you to be able to work interactively easily and fluidly and get feedback right away, but we also want to support a way for you to create clean, reusable, well-separated, well-isolated code. And how to do both of those in a fluid manner is not an easy question at all. And we don't think that anyone has solved that problem well. And we know it's an open question, and we're interested in continuing to work on it.
So here I have a question from Asif that sounds like a feature request. It says, is there any way I can group cells and then move or delete the group as necessary? I'm thinking of grouping based on heading, but I'm happy to learn of any other way.
Go for it, Fernando.
Yeah, I'm pasting right now. Paul Ivanov, I'm pasting group cell management. I've pasted in the so Paul Ivanov, who's one of our core developers who used to work here at Berkeley up until recently, already has coded an extension to do that. And I personally use it. It's really nice. We haven't merged it because it still has a few quirks in the UI. He hasn't had, unfortunately, the bandwidth to work any further on it recently. And it doesn't work across notebooks. You can't select a group of cells between notebooks. It only works inside of a single notebook. But it is super useful. I have it installed on mine, even though it's still a little quirky, because it lets you do exactly that. Select an arbitrary group, and it even does non-contiguous selection. And then once you have a group selected, you can cut, you can paste, you can move, you can do whatever you want with it. It's very, very handy. Still a bit rough around the edges, but I just pasted the link to the tool.
Good. Then I have a question now. I want to know, we're going back to IPython in education. I want to know about the grader idea and how, as you know, Fernando, I sent you tons of emails many months ago about this, thinking about, is it possible if I were to write a notebook that is an assignment that the students write some code and then the answer that code spits out, I can sort of automatically somehow check it that it's correct, and so it's auto-graded. What's the story there? What works? What is in the works? And what's the wish list?
Well, I can imagine why, with 3,000 students, this might be relevant to you. So the IPython dev meeting in Berkeley happened about a month ago, and Jess Hamrick, who's a graduate student at Berkeley, has been doing some work in this area, and I had started to think about this separately, and so Jess and I have sort of started to work on this together. There's a new repo under the Jupyter org on GitHub.
I'll paste the link. I'll paste the link.
And there's a couple different things that we're focusing on. One is the creation of assignments. And the idea there is that as an instructor creating an assignment, you want a way to write a notebook. And as you write the notebook, you write the question and the solution. And you may want to add some sort of code that verifies that solution. And for now, I'll call that a test. So for example, you could say, the question might be, write a Python function that solves this differential equation. And then as an instructor, you would actually write that Python function. And then you would, below that cell, put some tests, maybe assert statements, or you would use some other testing library. And when you assign that to students, there's a couple different things that have to happen. One is that obviously you need to remove the solutions, and you would want to put something in its place, right? You want some sort of stub that says, type your solution here, students. And furthermore, at times you don't want to remove an entire cell. You may want to leave, for example, a function signature and docstring, but remove the body of the function that's the solution that the student is going to fill in. And so we actually have a command line tool. It's called nbgrader, and the first subcommand that we're working on is called assign. And when you do nbgrader assign, it does all these steps. And in addition, there's an extension, a notebook extension, that allows the instructor, when they're authoring the assignment, to tag the cells based on the role that they play in the assignment. For example, for the cell that has the tests that are going to verify the solution, you can tag that as a test and assign a certain number of points to that that will happen when it is graded. And so that's sort of the first part of it. And at the end of the day, nbgrader assign produces another notebook that has had all these transformations done, and which you can then distribute to the students. So that's the first part of it. The second part is that you're going to get back, in your case, Lorena, 3,000 of these notebooks, and you're going to need to figure out what to do with them. And so there's two different grading modes we're working on. The first is automated grading, and the second one is a form that would involve human interaction, actually looking at the notebook, interacting and typing comments into a form, etc. For the auto-grading one, the rough idea, again, this is driven behind the scenes using nbconvert, and you would say nbgrader grade and then the notebook. And we begin by stripping all the output of the notebook. Then we run the entire notebook, and the auto-grading part of this consists of walking that notebook, looking for the cells that were tagged that should be graded, and all we do is check that there is no output in that cell. And so this is the one abstraction constraint. Basically, you need to write your tests as an instructor in a way that there's no output. So for example, an assert statement is a perfect way of doing this, right? If you assert, there's no output. If it succeeds, if there's a problem with it, you get output. And the part we haven't quite figured out is what do you do with the tallied scores. We're thinking either writing it to JSON files, CSV, or possibly even dumping it into a database. And so that's something we're still working out. The other is the more form-based grading, and in that mode what we're doing is we are converting the notebook to HTML and then embedding a Google form. And you basically get a web page that has a split view. The top is the Google form, and that scrolls independently of the bottom half, which is the notebook. And so as an instructor or in a peer grading context for large classes, individuals could look at a notebook, and in this view, our assumption is that the auto-grading would have run first, And so cells will be colored based on, for example, whether or not the test for that cell passed or not. And so even just with a quick visual scan, you can look down as an instructor and see, okay, everything is green, they got this right, but I need to go look at their plots, and the Google form has a rubric or some form control that allows me to grade that part of the notebook. The challenge with the Google Forms approach is that the data from the Google form goes into a Google spreadsheet, and so you end up with data in a separate location from the auto-graded data. And so, again, this gets into sort of the workflow, and right now as it stands, you as an instructor would have to write, either download the CSV file from Google and then figure out, well, how do you want to combine this different grade data, and that's still painful. This is something that both Jess and I will be using over the coming year. We'll be working on it, and we're trying to strike a balance between keeping it simple, but also making it powerful enough that it's useful to a large number of people. We've found that in general, because of the different teaching styles and teaching contexts that people have, it's really easy to make teaching tools incredibly complicated. What's challenging is to identify the common abstractions that all of us are going to need, and that we can all sort of live with the simple version, even though it might not do every last thing that we would want in our particular context. So that's a quick overview of NB Grader. I would say it's not quite ready for public usage, but probably will be, at least for people to play around with in the next week or so.
Oh, that's very good. That's very good.
I think I was looking at the question log, and Michelle Gill has had a question sitting there that I don't know if you can put that one up. Some of the others that are still open we've actually answered, but I don't think I can close them. So
is this one, if anyone has used IPython Notebooks for data analysis and
yes.
laboratory courses?
Yes, and I think Brian, I was thinking Jennifer, maybe you can comment on Jennifer Clay's course, which is the closest I can think of.
Well, actually, we have a faculty member in our department who has used the notebook in introductory physics labs. Mm-hmm. It would be great to get him involved in this discussion. I don't know too much about exactly what he's done and how he's used it. But this is something a number of us are thinking about.
Yeah, I can certainly say that when I was in physics in grad school and I taught undergraduate introductory labs, we used MathCAD was the default tool for the lab. Basically, that's how the lab instruction was given to the student. There were these little rolling carts with a computer that they would take to their experimental station, and then they would follow the MathCAD notebook type template, do their data collection, do their plots, do their analysis, and print that and turn that in as their lab report. And obviously, if I was teaching that today, I would make those things as notebooks and have them type in the data there, maybe type an ancillary CSV file or something, and then actually run the analysis right there. So modulo all of the grading caveats that Brian was talking about and the content distribution caveats that we talked about earlier, which still apply in a lab context. Kind of class materials and grading are still issues there. The actual usage for a data analysis lab-oriented course, I think would be perfect. I would, or at least pretty good.
Yeah. So Lorena, how are you handling grading today?
I have separate assignments. We've created assignments in the Open edX platform for courses. So, by the way, in case you didn't know, the way we're running this course as an open online course is we have installed a customized independent version of the Open edX platform on a cloud service. Okay. And this platform, of course, has a variety of problem types that one can embed as graded assignments. And for each module, we're creating some small questions where they could have a numeric answer or they could be multiple choice. And then we have one coding assignment where the students read, the platform allows for rich markdown with equations and everything, so we write a problem description inside the course platform, and then we've done the solutions and written a code that solves it ourselves, and then we search for numeric answers that they can give if they've got the code right. That they can enter numeric answers in the system.
Okay.
And there was it's not perfect, of course. No auto-grading. I mean, auto-grading is like the holy grail of online education. Nobody's solved that. Nobody's cracked that. But it's not a bad system. We can, for example, give some wiggle room on the numeric answers, so that given that the answers could be, floating point, or people could have small differences in the order that they have executed things, and answers could have slightly different results. We can try to anticipate potential error bars, if you will, in the answer, and build that into the grader.
So looking at questions, I don't know, Lorena, I think you can close. We have a few that we can close. I see one that I remember we haven't looked at from Greg, the one that has a +6. What have Lorena's students done with the notebook?
That she wasn't expecting, that most surprised her, that she didn't know could be done. I wasn't expecting them to print them out.
Me neither, actually. That surprised me a little bit.
I wasn't expecting them to print them out, actually. So far, let's see. So the students in my classroom, they're the students following the course online. And of those students following the course online, I think many of them are not students. They're really colleagues that are just interested in this form of teaching, and some of them have already been writing some alternative versions of some of the homeworks and have submitted them as to the assignment bank.
Oh, cool.
But I really can't think of anything that I've seen students doing with the notebooks that that would answer that question, actually. Something I wasn't expecting, apart from printing.
Yeah. I see another one here that I think it's the only one in the question bank that we haven't gone over, from Christian Onu, the one towards the bottom. It might be useful. Do you want to put that one up?
Okay. Yes, this is my first time using this Q&A system of the Google Hangout, so that's why we haven't been so slick with it.
No. It's great. Yes, it might be useful if the auto-grading system being discussed could be developed. So, for example, when teaching software carpentry workshops, instructors could project students' answers in real time. I have seen the iClicker used in this way.
Yeah. No, I mean, I think, right now we're focusing on out-of-class assignments, where there's really some sort of workflow where you distribute it to students, they work on it on their own, and it comes back and you grade it. But obviously, a lot of us are using the notebook in class in an active learning context where the students are coding right there and working exercises. And I think what you're saying makes perfect sense, and we'll have to think about it and work on that.
And it's a ton of work.
Exactly.
But one has to keep things within scope, and there's tons of different tools for different things. I combine different tools in the classroom, and I use student response systems in the classroom. I use Socrative in particular. It's one that students can answer questions with any device, or they're in front of a computer, so they can go on the web page, and I often have pre-prepared quizzes, short quizzes, or you can have an open short answer question where you ask the students a question and say, are you confused about any of this, or what do you think about this, and they can type in their answer, and you can see the answers popping in live anonymously on this sort of feed. So there are other tools that one can combine for, I don't think the notebook needs to answer all of these things.
Yeah, scope is definitely something that we need to exert inward pressure on regularly.
Yeah. And it's pressure. It's a tricky act, because it's not like we want to be mean to anyone, and often even ourselves. There are things that even we would like to do or have or whatever, and we even have to be kind of rough on ourselves in terms of, well, that would be a great idea, but honestly, either we can't do it right now, or maybe we shouldn't do it here, and it should be done separately, because the amount of interlocking complexity. I mean, the problem is. Complexity kind of grows. I don't know. It's a superlinear. It's some form of superlinear behavior with the number of things you throw in. It's definitely, probably far worse than quadratic, and so we constantly have to worry about the sustainability of the project. Right? We're not doing this as the IPython Jupyter effort is not a prototype anymore. This is not a personal toy effort of a couple of us anymore. This is really something that is used in production, and we take very seriously the fact that people like you, Lorena, but many others, right, have actually invested your own time in creating material and content with this. So we can't just come around and say, oh, we're going to try these 50 crazy ideas, and wow, the project became unmaintainable, and next year we can't do anything. So okay, we're going to go and do something else in research, and Brian goes and does whatever he does at Cal Poly, and I do other stuff here at Berkeley, and we kind of disband, and we get different grants on other topics, and that's the end of it. I think it would be a horrible, in a sense, breach of trust to the people who have actually made the project valuable by investing your own time and effort into creating with it. And we don't want to do that, right? It's not just that we care about the project. We also feel that right now the project is something where the community of users is part of the project. And therefore we have to be mindful of what do we do that could potentially, even if it sounds like an appealing idea in the short term, that could potentially negatively impact the project in the long run.
But so I think we should probably close the conversation today. We've gone over the hour quite a bit, and we've lost about half of the viewers in the meantime, in the last few minutes. So I think we should wrap up. And but just with one statement that in fact if I believe you'll agree that the use of IPython notebooks in education has been a watershed, right? It really has been very impressive to see how people are adopting it and so enthusiastic about them. And did you anticipate that?
I would say that we had hoped for things like that, but I think we've been somewhat surprised by the speed at which it has been adopted, and by the enthusiasm with which people have adopted it, given that it was still a new tool, a tool that was difficult to install, that had a lot of limitations at the beginning. I think we were, at least speaking only for myself, I have been surprised by the amount and the enthusiasm and the patience that our users have had, even when some things are really unacceptably broken for a long time, and people are still willing to put, as we were saying, their time and effort into using it and building with it. Obviously, we had hoped it would be successful, but there's a difference between hope and reality.
Yes, I think that they're terribly successful, and I'm really a happy user as well. I do have I remember the last request before we close the call. Numbered equations is my last request. The numbered equations are still. We added some JavaScript hack in the CSS, but they're not perfect.
Okay.
Yeah. That's something we've worked on some, and unfortunately, it's not simple.
Okay. All right. That's my last request for the wish list there. Well, let's wrap up. I thank you very, very much, Fernando, Brian, for agreeing to have this conversation with us.
Yeah,
thanks for inviting us.
Yeah, and thanks for all your work that you're doing with the notebook. It's absolutely fantastic.
Absolutely.
I'm glad you like it.
The only reason we can be here is because people like you are doing great stuff with it. So thank you.
Absolutely.
Bye-bye, guys.
Bye, everyone.
Thank you.